finish the first part. But since if we keep on tackling the second part, it might take too much time because if we don't have a breakable, so all I can talk is very slow. So we can only choose one of the arrow type and how to calculate arrow and represent things in arrow type. So that's what we did for the first chapter. Then we jump to, doesn't mean we leave the other part of chapter one behind. It just means we postpone the other part of the chapter one to the point when we need to use it. So bear this in mind. It just mean we postpone something. It doesn't mean we give up or we just forget completely. Okay, then we come to the chapter two. What we did in chapter two is I try to teach you guys how to do the real correction. Because there are many you want to say error is fine. There are many like it means that it's non-standardized. So it means that if I want to standardize everything, what am I supposed to do? And there are many factors. Includes now basically we are talking about tape, mainly about tape. And you might wonder, apart from tape, anything else? Yes, I told you guys, we have other things to do the distance. Because in chapter two is about, it's regards distance measurement, right? And we have many tools to do the distance measurement. The simplest one, of course, is tape. Because you don't need anything to be set up. You don't need battery. You don't need GPS. You need nothing at all. You just need a tape. And tape can be big, can be small. And if you need longer one, probably you need a steel tape. Otherwise, you can just buy some small, like 10 meters long tape, and you can do the proper measurement. So tape is easy to use, but on the other hand, tape causes probably the hugest mistake as well. You might wonder how come, because once you use a tape to do the long distance measurement, like 1 kilometers or 2 kilometers or something, but the thing is that your tape only have 10 meters long, and you can think about how could you make an accurate measurement? You of course you're going to make a lot of mistakes. Why? Because one, the slope, because the elevation of the ground, you cannot put the tape evenly on the ground, so that might cause an error. And the other one is that if you have a higher temperature or low temperature in comparison to the standardized temperature, then that might elongate or shorten the measurement itself, or the tape itself. So if that is elongated, it means that you underestimate the whole real distance. If that is shortened, it means that you you overestimate the whole distance. So you have to do some correction to correct all the overestimation or the underestimation in order to get a standardized one. That's one of the we call the error correction. The other one is about the force. If you pull the tape harder, and they all have a tension force, and the tension force will stretch the tape itself, and that might elongate the tape a little bit. Although it's a little bit, but think about you measure 1 kilometers, that cause some non-small mistakes as well, or errors as well. And that's another thing. So we have to compare. If you use the standardized tape, how are you going to standardize your distance, your measurement? That's another one. So we have a temperature force, and also we have something called sag, and slope first. The slope first. You also have to correct the slope. You use the tape, not only tape. Use other instrument as well. Sometimes if you're in what your interest is about the horizontal bit of from A to B, the distance between A and B. But the thing is that you can't do the measurement straight away because there might be a lag or something hinder you from doing all this kind of thing. So what you're gonna do is you might use some slope, mountain or something, or here, so climb to the here and the other side and measure that. Of course, this must be straight, must be vertical. Otherwise, it causes another error as well. So today I will correct this kind of error as well. So once what if you this one is not vertical, it causes another error as well, because it use trigonometry, right? If you how do you make the slope correction? Because suppose that is theta, and you climb the to this mountain, and then you measure the AC distance between the AC. So what you get is like you get one, for example, like K, the distance of AC is K, and so AB will be K times cosine theta, right? That's what we call the correction. There is of course theta normally is very small. Otherwise, it cause mistake, huge mistakes. Why? Because if AC is quite long, you can't guarantee it's vertical. It might look vertical, perpendicular to AB, but the thing is if BC is really long, it's hard to guarantee. It's complete perpendicular, or ideally perpendicular to this one. Because, but when BC is smaller, you can say it's approximately it won't cause too much of a mistake. So that's the reason you even use slope correction is supposed to have a very small theta. We call aberration as well. If this one is too huge, you use this approach, it causes a lot of a huge error as well, because you can't guarantee BC is the length between BC is vertical in so that's another problem, because you rely on trigonometry. This speed must be completely vertical, otherwise it cause some error as well. Okay, so this is another one. So this is another one, and then later on we talk about sec. We talk about sec, and I can't remember. I asked you guys to do some homework. So let me briefly take a look at the homework again, and then fortunately, I still some of the trace still live here, because sometimes got. Okay, so I asked you guys to do homework about regarding. I still remember probably this bit. So there are some sec. You do some of the sec correction. So last time I talked about pretty much all of them already. You do the temperature correction. So based on the information, this length basically is not is a length for the span. You see, there's a span, or it's called pay. There's a span. So each one you measure over the this one. So you mean you set the pack over here, and then you stretch it. But the thing is that if you don't pull hard enough, you have something called sec over here. So this sec will elongate. The nominal. This elongate this nominal distance will be larger than real distance. You see, the real distance is over here, or you can call the standardized distance. If you think about you have a standardized tape. So this distance is this real distance is shorter. Supposed to be shorter than this one, but since your tape is deep into this one, fall into this part, so of course it's pulled by the gravity. So in this case, it's elongated. So that cause some errors. So these errors must be considered as well. Okay. Apart from this one, you also have something called the elevation as well. There is a edge for the elevation as well. So this must be correction as well. Okay, so the first thing you need to correct is your temperature. This the temperature. Here we just a quick review, because I actually do homework as well. So in some sense, we already finished all this bit last week. This week we just no, not this week. We just spent a couple of minutes to make sure everything correct. Okay, so we probably have to call a roll in the after first section. I don't know. You always have a very low participation rate. I don't know why. It means a lot of you are going to fail this course. So take seriously. Is regard to your graduation as well. Okay, so because if you don't participate, how do you know where the progress is? How could you finish the homework by yourself rather than just copy others? And then how can you finish the essay or all this kind of thing? It's almost impossible. So participate in every lectures. So continue. So this is your nominal tape. So nominal be elongated. You have to correct it, and also you have to correct the temperature as well. Temperature correction. So do the temperature correction. All these correction first. Temperature correction, we call it a thermal expansion coefficient. I thought to the last time we already talked about how to do this. If the temperature is higher, then is temperature elongated, is overestimate. Elongated, it means is the underestimate the whole distance. So you have to plus something. So it is plus something. If the temperature is low, you have to minus something. So this is one of the criteria, and then they are same. One is by the internal force, by the thermal, by the heat, by the heat itself, by temperature itself, and the other is by the your external force, by human's force. And this force can also be measured. Think about this force. Normally people don't do this measure, but if you want to be very precise, or if you use the robot to do the measurement for you, and then you can measure the force. You can tap some sensors in the hands of the robot, and then the sensor can detect the how many newtons the robot pull on the tap. You can do it, of course. So you of course, to be very, very, very precise, they are not really independent, but just follow timing and for our purpose, they can be treated just independent. For example, like a sec is also related to your force as well. So in some sense, it's also related to this one as well. But they'll just they'll be treated independently. So they'll be treated independently. So we just skip this bit. Okay, so we finished the temperature within the pool. We also have the I want you to put together, put these two together. I also ask you to do the sec correction. And second one, we basically we don't do much about the derivation, but we just based on this formula. This is L is a length, as a length, and also W W stands for the indeed is the weight force. Here is a weight force. Is your weight not more than weight force. Also, you have a WC is a weight force, but you also have to times this L, times L. So it's proportional to the square, and P is your pull as well. Is a pull as well. So put all this together, so you can think about how to do a bit. So this one is a correction, an error generated by the first bit, first bit, and so on. You have a second bit, the second sec, and the third one. Keep on going. So adding up, then you have all the errors. So all the errors. So omega is here. Omega is a W. Maybe it's omega is better. Omega here is your weight force. So it's supposed to have m times gravity. So omega is m. This is m. M is your the mass times gravity. So this is a mass force. This is a mass force. So or we call weight force is over here. And you square them. You shift this outside. Then put error. All the distance. Error is the measurement. You measure from your. So error basically is your nominal distance. Your nominal distance. Nominal distance means the readings on your measurement on your tab. So use this tab, and this is the reading. The reading when you read is a 29.988. Normally, the tab. I don't know. Normally, tab you don't have a such precise measurement up to 0.98 APA. Maybe yes, maybe not. Normally probably is 29.98. So to get another 0.001, probably need much more precise tape. Okay, so that's the whole story about the do a correction. And you might wonder anything else. Yes, there are more for the it's more than like temperature. Also we have for the slope. Here you don't you also have for example like this example you also have to correct the slope as well. You have a slope as well, but you will make things much more complicated. But in this case, you also have to consider about slope as well. So you have some correction over here. Let's just briefly take a look at where does the slope kicking. And so this is a slope. You also a slope correction over here. Yes, it's a slope correction. So slope correction is over here. Of course, they use some. We have some way to measure slope correction, but here just use some formula. Of course, you can resort to the formula if the slope elevation is low, and then you can approximate the slope based on this formula. And probably we won't go through all this formula, but just maybe we went through last time, but if not, we just treat as given. We don't prove again because it might just take too much time doing all this. Okay, so you can also have a tab correction, and this might be the approximation. Approximation. It means that it doesn't really rely on use cosine something. But nowadays people use the calculator, and the calculator is all scientific one, and even you can use some simple programming. So you can instead of you can ditch the approximation approach. You can just use the precise cosine bit. So this will make it's much more accurate. Otherwise, this probably is another approximation of of course, when the value when the aviation is very low, when the theta is very small, then this one is a good approximation to the real one. So it means this one it means they won't make any big difference. Maybe just a little bit, tiny winning a bit. Okay. Now, last one we have to introduce as well because it's not really people don't care about this arrow too much. It's called mean sea level correction, and it's not popular. It's not. I mean, in the real surveying, people don't care about this one because it normally happen in the long distance. If you try to measure the distance between A and B, the long distance, then this time you have this kind of consideration. Otherwise, indeed they are pretty much this length, they are pretty much or you can say very identical because if the length, if this inclined angle is very small, it means very small. It means or this one, I mean, you stand on the ground and if you do some math, maybe we need 1 kilometers or something. Indeed, you won't get too much difference. They're pretty much. But if you measure something over like 100 kilometers or maybe 200 kilometers, you make some difference already because the Earth is a round one. The Earth is a round one. Is global, right? It's a round one. So in this case, if you want to if you treat as the distance between A and B, normally we treat like I want to measure the distance between A and B, but indeed you are not measuring the mean sea level distance. You are just instead you are thinking about measuring the straight line, but it's not straight line. In this world, there is no straight line. Because why? Because in this world, is everything is pulled by gravity, and the Earth is also a global one. It's a round one. So there is nothing called straight in this world. Maybe in this universe as well. Because everything is influenced by gravity. So more or less being pulled by something else, by external force. So this is an ideal world. There is no such thing. So the best one is you have something called standard one. Standard one is you think about you want to measure AB. Indeed, you are thinking about measuring this one, the mean sea level. You measure about mean sea level. But instead of measuring this mean sea level, it's a standard. Mean sea level is the standard one. Otherwise, it's hard to compare these two. If you this AB point AB, if you stand on the ground, maybe stand on different part, you stay in the mountain or something, do the measurement. Are they the same? Are they still A to B? So it's hard to do a comparison. So normally we have a standard one. It's called mean sea level. But mean sea level is but next question in my race, is mean sea level fixed? No, mean sea level is not fixed. Mean sea level is just the surface of the sea. They are not fixed according to the tide, according to the gravity from the moon, from the sun. It fluctuates maybe hourly or maybe it's minute, based on minute. I mean, maybe, mean sea level is not. Of course, we have a mean over here. So I mean sea level. Sea level is keep on changing. So you have a mean. I mean, it's do the average. But even the mean one is still changing as well. It keep on changing as well because depends on how much time you in particular government. So they so recall the sea beyond it. So for example, if there is a cliff in some part of Guangzhou province, I think not Guangzhou, in Hangzhou, I think in Zhejiang, maybe in Hangzhou or something. But anyway, so they choose one coast and set up a level, so they can measure the sea level. Measure. So when the tide comes in the high tide and the sea level is supposed to they record this one. So this is basically is a measurement. This is a set up over here, a measurement over here, and then record the sea level for 1 month, for 1 month, and then they just divide by 30 days. Then you can get a mean sea level. So this is pretty much the way you get a mean sea level in China as well. Because the sea level is quite changing, so there is nothing called sea level. It looks like the sea level is fixed, but it's not. It's good. It's changing according to gravity and the date as well. So it keep on changing. So the gravity so keep on changing. And so nowadays the mean sea level, I think that this level in China is fixed in, I can't remember because that was a long time story. I read it. Probably it's 1980 something or something. Probably 20 years ago. They fixed the sea level technical. But is this sea level, mean sea level still be the mean sea level? Even nowadays you can maybe they change a little bit. So but they take that one as a benchmark. So at that time, the sea level they take as the benchmark mean sea level, and other sea level they might be changed differently. And every country you have a mean sea level. In China, you probably take this one. You choose one coast, and if you choose the other coast, so instead of choosing Zhejiang, maybe you choose the Guangdong, or maybe you choose that province, like the coast of Shanghai or somewhere, and then the sea level will be different as well. So it's completely arbitrary. The mean sea level is completely arbitrary, depending on the place you choose. But the main purpose is to do this as once you choose as a benchmark, so others can be referred to this mean sea level. So it's above sea level how much, under sea level how much. So this is a basic idea about so set up benchmark. Okay, so consider about this one. Now we are going to measure the distance between AB. Instead of get measure AB, normally you don't get AB because you are not going to stand on the sea surface to measure the sea level, the AB. So you're not going to do this. What you set up your tripod or your total station or your machine, and then you measure this, right? So basically, from your machine, what you get is this one. Okay, this one. Okay. So you got to do some correction. Otherwise, you can't get this mean sea level based on this. So this is a standard one. If this direction being converted to this direction, how much are you going to get? So this can be converted into this one. So this conversion is called correction. You make do some correction. All right. So let's take a look. It's quite easy. You can do this one. So basically, it's a easiest one because for example, this is O. This is the center of the Earth. The center of the Earth. So I know the radius of the Earth. Suppose this radius of Earth. R over here is the radius of the Earth. So and H and O maybe L probably is the measurement over here. H probably the whole one. Anyway, I presume I get H here. H means here. Of course, I have to check. Go back. I don't want to check again, so I just I assume it's over here. H is over here. Okay, so there are some discrimination between this one as well, but forget about it. So how are you going to? But that doesn't mean this one. Anyway, let me try not to use H and maybe use another one. Otherwise, now it's about arrow. So I just want to teach you how to do the correction straight away instead of going to this arrow. Of course, you can do the measurement arrow first, but we don't want to just try to get this one. Okay, so basically this is a part of the circle. This is a part of the circle, and this is what I this last time I do. So this suppose this is called theta, and theta is measured by AB. AB divided by is the basically what is the theta is this one measure R divided by this one AB. AB is the distance. Okay, so this is your radians. So this is called theta radian. Theta radian. Okay, this value is supposed to equals to the bigger one, big circle over here, big circle. So suppose the radius of this one is r prime, and now you get this one. So they are proportional. And in principle, this are A prime, B prime. You don't, they are not curve. If they are short, you can just use a straight line. But to be precise, I use something called curve. Okay. So what I gotta do now? AB is easy. I can get easy. So AB is this number times R straight away, right? So you can get AB straight away. So once here, and AB prime, B prime, basically is your error. You measure your measurement. You get this one. So this basically is R prime, your R prime, and this is your error. Of course, you must know R prime. How could you calculate R prime? Easy. R prime, what's R prime? R prime comes from R. This is mean sea level. Plus A to A prime, basically is the place you set up your tripod, or you set up you do the tape or something. Basically is the place you stand is above the sea level or under sea level. So in this case is above sea level. So above sea level, the length you do the calculation. And if you have GPS or something, you can easily get this one. Even your mobile phone, you can use some. You download some app, and then they will tell you. Of course, the telling come from the GPS. I connect to the GPS, the satellite, and then the satellite will calculate the position. Your position now is over the sea level. How much? They will tell you the length of your. Okay. So let's just and of course you have this one A prime minus this one minus this value by this value we will get this arrow new arrow. So this number will come from the derivation. I skip this one. If you like, you can do the correction. Is not our purpose. Our purpose is to get the straight away the main one. How do you get the number? If you have some good one, you don't have to go through the correction. Of course, if you are interested in correction, you can deduct them by each other, and then you can get the creation part. Okay, so far so good, right? So we pretty much finish this bit. Okay, let's just last glimpse about anything left. So otherwise we'll jump to the next bit. Anything left over here? Maybe not. So all you know, you pretty much have 5-1 temperature, poor force, sec, slow, MS, the mean sea level. So you basically have 5 correction. So we have 5 correction for what? For tape. This is basically for tape, mainly for tape. Mainly for tape. So if you want to shorten all this mistake on this error, you better choose someday a very close temperature and reduce it. But it doesn't matter if you can do the correction, but it won't be precise. Why? Because your tape might not be reacting to this formula, might be not be reacting to this formula. It's just a theoretical formula because it depends on how accurate your alpha is. Because alpha is basically based on the different materials. And your material might deteriorate a little bit according to time. So this alpha indeed is approximation. You won't get, in some sense, you won't get absolute accurate, but you can get the accuracy to some degree you like. To most of the degree, people agree. All right, let's continue. I think pretty much we have this one. So far, we know how to, the main two parts. We know how to do some correction, this one. And we also know some of the theory about the errors as well. So we pretty much have two parts enhanced now. Let's continue. You must remember all this bit you learned, because in the end, because now it seems we probably don't have in exam bit. So I tend to have essay bit. Depends if the participation rate is still such low. We probably have an exam, paper exam. Otherwise, say MSL is major something that's the reason I call it important. If you major long it matters. So it depends. I just what I mean is if you for short distance, maybe I mean like 10 kilometers or something. Maybe it doesn't matter too much because it's short. Even you do a calculation, it's just a minor one. But if you spend for like 100 kilometers or something, really it matters because a lot of time they really look like curve. Look at, if you look at this, if you set the 2 points, you kind of see, but indeed it look like curve. It's a gravity, they pull everything. So the curve. Okay, any question, just pop in. Let me know anytime. Okay, let's continue. So remember how you did this one homework. So if we have depends. I will, if the participation rate is higher, then we can just have an essay. We probably have what you learn. We just assign one pretty much like formal homework, and you just try to find some practical example, and then we can put as an essay as well. Otherwise, you have a paper exam. Paper exam is I would say is harder because of course it's harder. Okay, let's continue. And also we have some other correction. Probably we don't spend on time on other correction as well. You also have all this bit. You can, if you are interested in this bit, because they are all minor one. It's quite tedious. You can just end this, keep on correction, one change a little bit, and then do a little correction. So, okay, now we come to the next stage. Let me see if next stage is called. Of course, you have some other correction over here. This is the second one here to do the correction, but we pretty much skip the whole of this second one. But it's very important. We'll come to this bit as well. Okay. You see, even this chapter it comes like goes endless miles long. So probably this chapter probably is the longest chapter in all this one, because normally people do the distance measurement. So that's the reason distance is most important here. Okay, let's come to the second bit. Second bit indeed is much more practical. In a sense, like you are going to measure something over, for example, like 100 meter, 200 meter, or something this long. In this case, people tend not to use tape for simple reason. It's too painful. You have to measure many times, and there are some major errors as well. In the end, any other alternatives? to replace this bit, this tape. Yes, you can use electronic device measurement, EDM. And EDM in some sense is a general term. There is no simple one particular machine is called simple electronic device or is a brand or something. It's kind of like as long as you use electronic device, and they will call it electronic device measurement, and they can equip with the different kind of thing. You can use all sorts of electronic things. Let me. Yesterday I find out some bit, and then I can show you some of the measurement regarding the EDM, and then after looking at the general EDM, we will come back to the real one. Real one means to the for me, I think EDM is much more important than the tape. Tape, indeed, nowadays, very few people using tape to do the measurement for the long distance. For the short one, yes, it's easy and convenient. Some tape will cause a huge mistake, and also okay. Let's look at the one over here. I think it's the which one? The EDM over here. Okay, so let's take the EDM. EDM might device, and now we have to go on because previously called nothing we have to talk about tape. Everyone knows about tape, so we don't have to show you how tape and even how to use tape. We don't have to. But now when it comes to electronic device, we have to first of all we have to introduce the different types of the electronic distant device, and also how to operate them. Based on your operation, how do you do the measurement? How can you reach a conclusion about the distance? It's more than like this electronic device. You normally depends on the equipment you get. Normally, if you're proper one, normally they can measure distance and angles, and to some measurement, they can also to some device they can also measure the area. This kind of thing. So many things they can measure the vertical angle, the horizontal angle, and all these are basic one. Okay, so electronic device is of course the major device. It's basically between two electromagnetic waves. So basically use the electromagnetic waves to do the measurement. That's the reason it's faster because it normally is being transfer and run by the speed of light or the electricity, all these kind of things. So it can be very very fast. Okay, so EDM, EDM based EDM. You're talking this one also talk about you have other way as well. There is one called direct measurement. Direct measure is the one we mentioned. Is about chaining or taping. Basically, chaining just divide into different parts. Keep on measurement, or you can use tape straight away. So this is called the direct distance measurement, and we finished this bit already. We probably won't come back to this one again because it's a simple. You just focus on the 5 types of errors. The temperature, pool, also this kind of thing, and indeed, do people really do all this bit to correct their tape? I doubt it, but theoretically, yes, you have to do this to correct make everything into standardized meters. But do people really do this like this? Maybe not, because it's not really that important to have some millimeters difference. But to be precise, yes, you have to do this sort of thing. Okay, now let's come to the second one. Second one is called optical distance measurement. Optical distance measurement is called thermometry. uh, tachymetry. Tachymetry basically tachymetry is you have a tachymeter first. Tachymeter basically is also a machine. It's also one type of machine. Is a we all see what the type what the machine looks like, but so the way basically is the main purpose for this one is for measuring the distance as well. So the tachymetry. So this is the study of the measurement. The measurement. Tac means deep or something. So just the length. Okay, so also you have a horizontal substance. Horizontal substance, horizontal substance, we also have this one previously. I asked you to do the homework as well. So you have one people hold the substance bar. But now you combine this one with the optical one. So you also have the bar, but the observation doesn't come from your naked eye. The observation come from the machine itself. So this will be the optical one. It means you will see through the telescope. You have a telescope. So basically the telemetric, we have a telescope to look into this one. Okay, so all these need optical measurement, optical equipment, optical equipment. So you have a laser or something. I also have. Let's come to the other one. We call electromagnetic distance. So electromagnetic distance is good. Cannot be implemented in what? Suppose in the difficult terrains. It means if you're a lake, in this case, the electromagnetic approach as well. We'll come to this bit, how to do all this bit and the theory bit as well. So, all right. There are some timing for using this one, the timing for this one. So, for the shorter one, you are for 115 to 150 meters. Basically, these use what's the one? Magnetic or what? You probably see still called magnetic. So all this and the longer distance, you have EDM. Yeah, for this kind of distance, you have accuracy will be improved. If you this one probably is use the optical. If you optical one, probably you have this long. You have 1 in 1,000 arrows, and it's not huge, but if the distance long one is huge as well. But for EDM, for the overall probably means this one, the electromagnetic. So you have a different kind of approach, much more accuracy one. This is accurate one over here. So and it's good as well. Of this advantage of 100 kilometers, you have accuracy is 1 in 10 to power of 10 to power 5. So it's very accuracy as well. All right, so we'll come to this one. Of course, you need to rely on the we call the wave. Or this become either the light or either you use electric or everything you rely on wave. As long as you are not using the tape, in principle you are using the something wave. Wave basically you depends on observing the physical property. You can see, of course, you have some wavelength, the frequency or all this frequency, and they are quite different from this one. So some goes very fast, some goes this one goes very fast, right? And so some go very slow, like S-Way, it goes very slow. And infrared probably is the most popular one in our measurement, regarding the optical one, probably the most popular infrared one. So I'll show you the machine right after our break. Maybe we'll take a few minutes practice machine. Okay, let's take how many minutes? Break time. Let's take uh 3 minutes, I guess. Okay, so they don't what? Um, don't they are important. Like I said, depends on show this uh absolute accuracy. They will make no difference. So last race is not so important. Okay, let's 3 minutes back. Okay, one song after one song we are break. And actually,
You were the shine.